The Order of Time by Carlo Rovelli. Picture this: two childhood friends, absolutely identical in every conceivable way, living their separate lives. One settles into a cozy beach house by the ocean, while the other builds a home high in the mountains. Years pass. They work, fall in love, dream their dreams, live their lives in parallel. Then comes the day they finally reunite, and something's off. The mountain friend looks slightly older. Not dramatically, just a touch more weathered. His watch shows a few extra seconds have ticked by. He's actually experienced more time than his seaside companion. Now here's the wild part. This isn't some whimsical thought experiment or science fiction scenario. This is literally how our universe works. Time genuinely moves faster at higher altitudes than it does at sea level. The difference is microscopic, almost invisible, but it's absolutely real. And this strange little fact? It's just the opening clue in a mind-bending mystery that's about to completely unravel everything you thought you knew about time. Today we're diving headfirst into one of the most fascinating scientific puzzles ever tackled: what time actually is. Our guide for this journey is Carlo Rovelli, a brilliant Italian physicist who's devoted his career to quantum gravity and understanding the deepest fabric of reality. But here's what makes him special. He writes like a poet. In The Order of Time, he takes our most familiar concept, something we think we understand intimately, and examines it like a delicate snowflake. And as he turns it over in his hands, layer by layer it begins to melt away until almost nothing remains. This book has captivated millions worldwide because it does something remarkable. It transforms the most brain-twisting ideas from modern physics into something that feels intuitive, deeply personal, and profoundly human. It tackles questions that strike at the very heart of existence. Why can we remember yesterday, but not tomorrow? What do we really mean when we say time passes? And in those quiet moments late at night when you lie awake listening to time slip away, what exactly are you hearing? Let me make you a promise. If you stick with me through this exploration, you'll never look at a clock quite the same way again. You'll understand that the steady, universal tick-tock we imagine is actually an illusion. You'll start seeing the world not as a collection of objects frozen in snapshots, but as a flowing symphony of events. And you might just discover that the source of time, this great cosmic secret we've been searching for in distant galaxies, has been hiding inside us all along. This is the story of how time crumbles, and the beautiful, bizarre reality that emerges from its ruins. Let's jump in. We all feel it, don't we? Time. It's the most intimate companion of our existence. We're immersed in it the way fish swim through water. It's that relentless current of seconds, hours, and years carrying us from birth toward the great unknown. It's the background music of reality, sometimes comforting us, sometimes haunting us, always there as we drift off to sleep. The entire universe seems to unfold according to time's order. In Hindu mythology, they picture this cosmic flow as the god Shiva, forever dancing. His movements are time itself, the rhythm holding everything together. What could possibly be more obvious, more fundamental, than this constant river flowing through existence? But here's the thing. Reality has a habit of being nothing like it appears. We once looked around and concluded the Earth was flat. Surprise! It's a sphere. We watched the sun cross the sky and assumed it revolved around us. Nope, we're the ones spinning. And as Carlo Rovelli discovered early in his physics studies, our everyday understanding of time is just as backwards. In fact, nearly everything we intuitively believe about time turns out to be wrong. The story of modern physics is basically watching this illusion slowly disintegrate, piece by piece, like that snowflake melting in warm hands until there's nothing left but a puddle. The first piece to dissolve? The idea that time is the same everywhere. We naturally assume that 60 seconds for you equals 60 seconds for me, and 60 seconds for someone on the opposite side of the planet. One universal clock, keeping time for everyone equally. Except, it doesn't work that way. Remember our two friends? Time literally passes at different speeds depending on where you are. Closer to a massive object like Earth, time moves more slowly. This isn't some quirk of our measuring devices. It's written into the fundamental structure of the universe. Down at sea level, everything happens more slowly. The friend at the beach has genuinely lived less, aged less. His plants grew less. His thoughts unfolded more slowly. At lower altitudes, there's simply less time available. The genius who figured this out a full century before we had clocks precise enough to measure it was Albert Einstein. He started with a deceptively simple question. How does the sun pull on Earth from millions of miles away without physically touching it? His answer revolutionized everything. He realized that massive objects don't pull on things directly. Instead, they warp the very fabric of space and time around them. Mass literally slows down time in its vicinity. This is why things fall. An object doesn't drop because of some mysterious force yanking it down. It falls because it's following the natural slope of time itself, flowing toward where time passes more slowly. Your feet, being inches closer to Earth's center than your head, exist in a zone of slightly slower time. The reason you're stuck to the ground right now is because of this subtle time difference across the length of your own body. Once you truly absorb this, the concept of universal time just shatters. There isn't one time. There are countless times, a different one for every point in space. Rovelli describes it beautifully. The world isn't like soldiers marching in perfect lockstep to a single drum. It's more like a wild network of events, each dancing to its own unique rhythm. If we imagine the universe as Shiva's dance, there must be 10,000 Shivas, each dancing to their own beat. The snowflake has lost its perfect symmetry. But surely time still flows in one direction, right? This brings us to the second melting piece, the loss of direction. The difference between past and future feels absolutely fundamental to existence. The past is fixed, solid, done. We have memories of it, photographs, regrets. The future is wide open, pure possibility, filled with hope and uncertainty and anxiety. A glass falls and shatters into 1,000 fragments. Those fragments never spontaneously leap back together into a whole glass. Cause always precedes effect. This is what we call time's arrow. So where in the fundamental laws of physics is this arrow hiding? 19th century physicists went hunting for it, and they discovered something deeply unsettling. In the basic equations describing reality, Newton's mechanics, Einstein's relativity, quantum mechanics, there's no difference between past and future. If a sequence of events can happen, that same sequence running backwards is equally possible according to the math. A film of the moon orbiting Earth makes just as much physical sense played in reverse. There's only one exception to this rule, and it shows up in just one place: heat. This crucial connection was discovered by a French engineer named Sadi Carnot, born into what Rovelli calls, quote, poetry and rebellion. Carnot was obsessed with the steam engines emerging in the 1800s. He realized they worked because heat always flows from hot to cold, never the reverse. This simple observation became a cornerstone of physics, formalized by a Prussian professor named Rudolf Clausius. A bouncing ball can fall and bounce back up. Heat cannot flow backwards. Clausius gave this one-way process a name: entropy. Entropy measures disorder, and his law states that in any isolated process, entropy can only increase. It never decreases. This is the famous second law of thermodynamics, and it's the only equation in fundamental physics that distinguishes past from future. Every time you witness a difference between past and future, heat and entropy are involved. A ball rolling to a stop seems normal. A stationary ball suddenly starting to roll seems impossible. Why? Because the rolling ball stops due to friction, and friction generates heat. Even your thoughts, which always flow from past to future, produce heat inside your brain. So the secret of time's arrow is somehow hidden in entropy. But what exactly is entropy? Enter our next hero, Ludwig Boltzmann, a brilliant and ultimately tragic Austrian physicist. Boltzmann truly understood entropy. He realized that heat is just molecules jiggling around frantically. In a hot cup of tea, molecules zip around wildly. In a cold cup, they move sluggishly. Then he had his breakthrough. Entropy always increases, heat always flows from hot to cold, simply because of statistics. It's like shuffling a perfectly ordered new deck of cards. Shuffling naturally creates disorder, never more order. Everything naturally tends toward increasing disorder. The growth of entropy is just this natural drift toward chaos. This was genius, but it doesn't actually solve the mystery. It just pushes it back one step. Now the question becomes, if the universe is always getting more disordered, why was it so incredibly ordered in the past? Why was the cosmic deck of cards in such a special, low-entropy state at the beginning? And here Boltzmann delivers his most dizzying insight. He realized that the very concepts of order and disorder depend entirely on perspective. They exist only because we see the world in a blurred, simplified way. Think about that card deck again. We call a deck with all red cards grouped together, ordered. But it's only ordered because we're paying attention to color. If we examined every microscopic scratch and crease on every single card, every possible arrangement would be equally unique and special. The idea that certain configurations are ordered only exists because we ignore microscopic details and group things into categories. Boltzmann showed that entropy is precisely the number of different microscopic arrangements that our blurred vision can't distinguish. It exists because we don't, and can't, see everything in perfect detail. This leads to a shocking conclusion. If you could somehow see the exact microscopic state of the entire world, all its infinite details, the difference between past and future would completely vanish. Time's arrow, this flow that feels so fundamentally real, is actually a product of our ignorance. It's an effect of viewing the world through fuzzy lenses. Could something so central to our experience, the passage of time, really just be a kind of cosmic nearsightedness? The evidence is overwhelming. All the phenomena that mark time's flow are connected to the fact that the universe began in a state that appears incredibly special from our blurred perspective. Boltzmann's equation defining entropy in terms of this blurring is carved on his tombstone in Vienna, a fitting memorial to the man who discovered that time's river flows only because we see the world through an imperfect lens. The snowflake has now lost its unity and its direction. It's becoming a puddle. But the most devastating blow is still coming, the end of the present. About a decade before figuring out that mass slows down time, Einstein made another discovery. He realized that speed also slows down time. Back to our two friends. This time one stays put while the other goes for an extremely fast walk. When they reunite, the friend who was moving has aged less. For everything that moves, time passes more slowly. This has been measured countless times. A precision clock on an airplane runs slightly slower than an identical one sitting on the ground. This simple fact has an absolutely earth-shattering consequence. The idea of now is meaningless across distance. Imagine you have a sister who traveled to a planet orbiting Proxima Centauri, about 4 light-years away. You might casually wonder, what is my sister doing right now? Rovelli explains that this question literally makes no sense. It's like standing in Venice and asking, what is here in Beijing? The word here refers to your specific location, not some universal location. Similarly, now refers to your local time, not some universal time. If you could look at your sister through a super powerful telescope, you'd see her as she was 4 years ago, because that's how long light took to travel from her to you. That's her past, not her now. You might try calculating what she's doing 4 years after that moment, but that doesn't work either. Because of how speed affects time, she might have already returned to Earth and be 10 years in your future. So when exactly is now on that distant planet? The truth is, There is no now there that corresponds to your now here. Rovelli calls this the most astonishing conclusion in all of contemporary physics. Our present doesn't stretch across the entire universe. It's a bubble around us. For everyday life on Earth, this bubble is large enough that we can pretend to share a single now. But zoom out into the cosmos, and the illusion completely falls apart. There's our past, events that can affect us. There's our future, events we can affect. But between past and future lies a vast, extended present, an interval that is neither past nor future. For Mars, this interval is about 15 minutes. For the Andromeda Galaxy, it's millions of years. The notion of a single present moment, a universal now existing throughout the universe, is pure illusion. There's no great cosmic clock ticking off the moments of existence. The present of the universe is a meaningless phrase. So what does the actual temporal structure of the world look like? Rovelli uses a brilliant analogy, a family tree. For any person, there's a cone of ancestors in the past and a cone of descendants in the future. But there are also many people who are neither ancestors nor descendants, cousins, distant relatives, friends. They exist outside those cones. Space-time structure is identical. For every event, there's a light cone of its past and a light cone of its future. Everything outside these cones lives in that expanded present, neither past nor future. This is the strange new geometry of reality that Einstein revealed. The snowflake of time has now completely dissolved. We've lost its unity, its direction, and its present. What's left? This brings us to the final crumbling, the loss of independence. For centuries, we've been caught between two intellectual giants, Aristotle and Isaac Newton. Aristotle believed that time is simply how we measure change. If nothing in the world changed, time wouldn't pass. Time isn't its own separate thing. It's just a way of counting events, like sunrise or a pendulum's swing. Newton, however, imagined a true and absolute time, a time that flows completely on its own, independent of everything else, whether anything happens or not. Even if the entire universe froze solid, Newton's time would keep flowing, steady and unchangeable. This is the T in his equations, and it became our common-sense understanding of time. So who was right? The answer required a third giant to enter the stage, Einstein. Einstein's breakthrough showed that both were right and both were wrong. Newton was correct that there's something real existing beyond simple matter. This something is what we call space-time. But he was wrong to think it was absolute and independent. Aristotle was right that time is connected to change, but the thing it's connected to isn't just ordinary matter. It's the gravitational field itself. Here's the key insight. Space-time isn't a fixed, empty stage where the universe performs its play. Space-time is the gravitational field. It's a physical, dynamic entity, like an electron or a beam of light. It's a vast, flexible structure that can bend, stretch, and ripple. Time, slowing near a massive object, is just this structure being stretched. The universe isn't a story painted on a fixed canvas. It's multiple canvases, all interacting with each other. Time has lost its independence. It's no longer the king ruling over reality. It's just one of the dynamic players in the great cosmic dance. But even this isn't the final destination. Because we live in a quantum world, and when we apply quantum mechanics, strange rules to space-time itself, the last remnants of our familiar time disappear entirely. Welcome to the world of quantum time. Rovelli is a world expert in this field, called loop quantum gravity. This theory reveals that space-time, like everything else in the quantum realm, has three bizarre properties. First, granularity. The smooth, continuous flow of time is an illusion. At the tiniest scale, time doesn't flow continuously. It jumps from one value to another in discrete steps. There's a minimum possible time interval, called Planck time, an unimaginably tiny fraction of a second. Below that scale, the concept of time simply doesn't exist. As Rovelli poetically puts it, The good Lord has not drawn the world with continuous lines. With a light hand, he has sketched it in dots, like the painter Georges Seurat. Second, indeterminacy. In quantum physics, a particle like an electron doesn't have a precise location until it interacts with something. It exists as a cloud of probability. The same applies to spacetime. At the fundamental level, spacetime itself fluctuates. The clear distinction between past and future becomes fuzzy and uncertain. An event can be simultaneously before and after another event. Third, and most profoundly, relationality. A quantum particle only materializes at a specific point in relation to what it interacts with. Its properties aren't absolute. They're defined by relationships. This applies to time as well. The duration between two events isn't a universal property, but the result of a specific interaction. Time dissolves into a web of relationships that no longer forms a coherent backdrop. So after this long demolition, what's left of time? Nothing. At the most fundamental level we can probe. Time doesn't exist. There's no special time variable, no past or future, no universal present, no continuous flow. We've arrived in a world without time, a strange, windswept landscape of pure change. But this doesn't mean the universe is static or frozen. Far from it. The absence of time doesn't mean nothing happens. It means change is everywhere, but it's not organized along a single timeline. The events of the world, Rovelli quips, don't form an orderly queue like the English. They crowd around chaotically, like Italians. The universe is happening everywhere, all at once. This is perhaps the most radical shift the book offers. We need to stop thinking of the world as made of things that persist through time. We need to think of it as made of events. A stone seems like a solid, permanent thing. But look closer, and it's just a long, slow event. It's a complex vibration of quantum fields, a process maintaining its shape temporarily before eventually crumbling into dust. A kiss, on the other hand, is obviously an event with a limited duration. Rovelli's poetic insight: the world is made of networks of kisses, not of stones. We're not things either. A human being is a complex process. Food, information, light, and words constantly flow through us. We're a knot of knots in a vast network of chemical, social, and emotional exchanges. We're not beings, we're becomings. The physics describing this world of events doesn't need a time variable. The fundamental equations of quantum gravity, like the Wheeler-DeWitt equation, have no t in them. Instead, they describe how all the variables of the world change in relation to each other. Time, as Aristotle first intuited, is simply the measure of change. The theory just describes relationships between events. This is the barren, beautiful world without time. But if this is true, if time isn't real at the fundamental level, where does our experience of time come from? Why do we feel it flowing so relentlessly from past to future? This is where the narrative turns into a detective story. We're hunting for the culprit who created time. And like in the great tragedy of Oedipus, the detective might discover he's been searching for himself. The source of time isn't out there in the cosmos. It's here, with us. It emerges from our particular relationship with the world. The first clue is blurring. Remember Boltzmann? Time's arrow exists because the past had low entropy. But entropy only exists because of our blurred vision of reality. So our feeling of time is a direct consequence of not seeing all the microscopic details. Time, in a profound sense, is ignorance. Rovelli, building on work by mathematician Alain Kohn, shows how this thermal time naturally emerges from any blurred, statistical description of a system. When you can't see all the details, a special variable with time-like properties just appears. But this still doesn't answer the central question: why was entropy low in our past? This brings us to the second and most crucial clue: perspective. Maybe the universe at its beginning wasn't in a special ordered state at all. Maybe it was completely random. The reason the past looks special to us is because we're a particular kind of system, with a specific way of interacting with everything else. Rovelli uses a powerful analogy. For thousands of years we looked up and saw the entire cosmos majestically revolving around Earth. It seemed like the most fundamental feature of the universe. But we eventually understood that the heavens weren't turning. We were. The grand rotation of the sky was a perspective effect caused by our particular motion on this spinning planet. Time's arrow might be exactly the same kind of thing. Time's flow isn't a property of the universe. It's a property of our perspective within it. Out of the countless trillions of systems in the universe, some will naturally interact with the rest of reality in such a way that, for them, the past appears more ordered. We happen to be one of those systems. And it's only in such systems, where entropy is increasing, that life, evolution, and thought become possible. We don't live in a place where time flows. Time flows in the place where we live. This is where the story of time becomes the story of ourselves. That low entropy in the past, that arrow of time, is what allows the past to leave traces. Fossils, craters on the moon, photographs, and most importantly, memories in our brains. Without the one-way flow of entropy, everything would be perfectly reversible, nothing could be recorded. The past leaves marks, the future doesn't. This is why the past feels fixed and the future feels open. And what are we, as human beings, if not walking collections of traces? Our identity is built on memory. I'm not just this body existing right now. I'm my mother's embrace, my teenage adventures, the books I've read, the loves I've felt, the mistakes I've made. I'm a long, ongoing story, held together by memory's thread. As St. Augustine observed centuries ago, the past exists as memory in the present, and the future exists as anticipation in the present. Time, for us, is fundamentally a phenomenon of consciousness. Our brains are time machines. They're not designed to perceive some instantaneous now, which doesn't really exist anyway. They're built to compress stretches of duration into single perceptions, holding the past in retention and the future in expectation. This is how we can hear a melody. A song only exists across time, but we experience it as a unified whole, because our consciousness is a structure woven from memory and anticipation. This, finally, is the source of time. The demolition is complete, and the rebuilding is done. The uniform, absolute time we started with has vanished entirely. In its place is a much richer, more nuanced picture. At the fundamental level, there's a quantum world of events without clear temporal order. From our blurred perspective on this world, a statistical thermal time emerges. From our specific location within the universe, this time appears to have a direction, an arrow, that allows traces to form. These traces accumulate in our brains, creating memory. And this constant dance of memory and anticipation within our minds creates the profound, personal, emotional experience we call the flow of time. The mystery of time, in the end, isn't about the cosmos. It's about us. We were searching for the ticking of some great cosmic clock, but we were carrying the clock inside ourselves all along. The emotion of time isn't fog obscuring its true nature. The emotion of time is its nature, at least for us. And this time, our time, is precious precisely because it's finite. It's the brief circle of our existence, a miraculous combination that allows us to be here, to love, to learn, and to wonder. Reading the order of time feels like sitting with a wise friend under a starry sky, having the universe explained in a way that's both mind-expanding and oddly comforting. What Carlo Rovelli does so brilliantly is take a subject that could be cold and abstract, the physics of time, and reveal its deeply human heart. The most powerful lesson for me is this idea of perspective. We constantly search for absolute truths, for some objective view from nowhere of reality. Rovelli gently shows us that such a view might not exist, and maybe it's not even what we should want. Our experience of the world is shaped by our being in it, not floating outside it. The fact that the sky appears to revolve around us isn't a lie. It's a truth about our relationship with the cosmos. And the fact that time flows for us isn't some illusion to dismiss. It's the very foundation of our identity, our memory, and our capacity for connection. This book reminds us that we're not detached observers of the universe. We're participants. Our ignorance, our blurred vision, isn't a flaw to overcome. It's the very condition that makes our world and our experience of time possible. There's profound humility in this idea. It suggests that the deepest truths aren't found by trying to transcend our humanity, but by understanding it as part of nature's fabric. So how can we bring these grand cosmic ideas down to earth and apply them to our everyday lives? First, we can learn to embrace the present, not as a fleeting instant, but as our unique bubble of reality. Rovelli shows us there's no universal now. The only now that matters is the one we're living in. Too often we get trapped in the past, replaying memories and regrets, or we get lost in the future, paralyzed by anxiety and what-ifs. This book is a powerful invitation to fully inhabit our own localized present, recognizing it as the only place where life actually unfolds. Second, we can see ourselves not as fixed things, but as evolving events. You're not the same person you were last year or even yesterday. You're a process, a story constantly being written. This frees us from the tyranny of a static identity. It gives us permission to change, to grow, and to let go of the parts of our story that no longer serve us. You're not a stone. You're a river. Finally, we can find a new relationship with the passage of time itself. The book ends on a surprisingly tender note, reflecting on mortality not as a terrifying void, but as a natural part of the flow. If our lives are brief circles, then every moment within that circle becomes infinitely precious. The pain we feel from loss is inseparable from the love we're capable of. The sting of time's passing is what gives each moment its sweetness. That was our journey through The Order of Time by Carlo Rovelli. We've touched on the major themes and mind-bending conclusions, but I'll be honest with you, a summary can only ever be a map. The real magic happens when you walk the territory yourself. It's in those quiet moments of reading, when a particular metaphor or elegantly simple phrase lands in an unexpected way, that the deepest understanding blooms. This podcast exists to help you decide if this book deserves your precious time. If anything we've explored today has sparked your curiosity or touched something in you, I'd encourage you to pick up a copy. Reading it isn't just an act of learning. It's an experience that can genuinely shift how you see the world and your place in it. You'll find a link to the book in the description below. Also, if you found this summary valuable and want to keep exploring transformative books together, please take a moment to hit that like button and subscribe to the channel. It helps us grow and make sure you won't miss our next adventure into another life-changing text. Let's keep growing and wondering together.